Here's the geometric definition of a parabola, which we talked about in class. We did a little bit of an investigation on this. It's the set of all points in the plane such that the distance from the point you're testing to a fixed point f called the focus is equal to the distance between P and a fixed line L, the directrix. So the important thing here is that the focus, for this definition, the focus and the directrix are picked in advance. And then you look at all the points P so that the distance from P to the focus is the same as the distance from P to the directrix. So, for example, here's a picture. Here's the axes, 0, 0. Here's the focus. There's a little x here. I don't know if you can see it too well in the video, but here's a little x at 0, 1. And here's the directrix. And I picked those so that this was 1 unit up and this was 1 unit down, as we did in class, so that the point halfway in between, the point right in on the line of symmetry, the y-axis in this case, right halfway in between, the origin, is going to be on the parabola. That's the one easiest point to find, is the point halfway in between the focus and the directrix. And then the other points are a little harder to figure out, but we figured out that it kind of swoops upward in both directions, and it's symmetrical about this line that's through the focus and perpendicular to the directrix. That's called the axis of the parabola. And then we guessed that it looked like it was going to be our familiar parabola, so a quadratic equation. And then we figured out that that's actually going to be our guess. Our guess was correct. We figured out that the equation, and I won't review that right now just as I save time, turned out to be x squared equals 4y is one way to write it. And that was with this particular case where the focus was 1 unit up and then the directrix was 1 unit down, so that in the middle was the origin. Well, what if we... God, why does it keep... How about don't show this message again. What if we pushed this focus up or down and then also moved the directrix so that the midpoint would still be at the origin? So that, in other words, that this focus, if the focus is at, so we figured out for our example, when f was equal to 0, 1, and the L, I called it D for directrix in class, but it's the book uses L, so we'll go with that. That was the line y equals minus 1. If the focus is at f equals 0, comma, let's say P, to have a name for that that number, the height of the focus, and L is equal to, well, let's see, in order to keep the midpoint in between at the origin, we'll shift that down to minus P. Then it's not too hard to show, just the same algebra that we did. It's just that a P comes in. X squared equals 4py. And that's going to be a form that we're going to use for the equation of a parabola. It's not going to be utterly crucial for a lot of things, but it's a nice thing that relates the geometry to the algebra. So that's one version of the parabola. Let's do another example, though. What would happen if I did it sideways? What would happen if I still want the vertex to be the origin? So I want the parabola to pass through the origin, but I'm going to take a focus. I'm going to take it at 1/4 to the left, so it's going to be at negative 1/4, comma 0. So what if f equals negative 1/4, comma 0, and the directrix is going to be, now it's going to be an x equals line. So here it's going to be x equals 1/4. And now, in principle, I could choose those to be any two different numbers I want. The reason I'm choosing them to be equal and opposite is so that right in between is the origin. And that means that at least, whatever other points are on this parabola, at least the origin's going to be in there. Okay. So, let's see what happens. If we do the algebra, I'll skip the algebra again, but we're just interchanging the roles of x and y here. And I claim, let's just say I claim, and we'll check it experimentally instead of proving it algebraically, that we're just going to get y squared equals minus x. And interestingly enough, that's 4 times minus 1/4. x. So again, if this is p, then it's showing up as a 4p, but now instead of x squared equals 4py, I claim it's y squared equals 4px. And so that's going to be the equation for a sideways parabola. And where we highlight the role of p, which talks about the location of the focus and the location of the directrix. Well, let's check that with the graph. It's supposed to be y squared equals minus x. And I went ahead and graphed the parabola. So the vertex certainly is at the origin. Here's another point that's fairly simple. It's minus 1/4, comma 1/2. Let's see if that makes sense. Well, sorry, minus 1/4, comma 1/2. So here, it's the distance here is 1/2. Notice the scale is a little weird. That's why I was getting confused. The scale is not completely square here. I probably should have squared it off. But the scale, the distance here is 1/2. So this is a point that's 1/2 a unit away from the focus, and it's 1/4 plus 1/4 is 1/2 away from here. So let me actually fix that. I just didn't think to fix that. Real quick. There we go. Okay, so now it looks a little bit better. So this distance really is equal to this distance. So let's see if that satisfies the equation. So the claim, does the point minus 1/4, 1/2 satisfy the equation? Well, yeah, because if you take 1/2 squared, that does equal minus of minus 1/4. Okay. And the reason I highlighted that one is that's the other, there's two other points that are always easy to plot on a parabola given the geometric description. If you start at the focus, you go parallel to the directrix, we know, if we're going parallel to the directrix, we know how far we are from the directrix. This is distance p, and this is distance p, so this is 2p. So if I want to go out and get a point that's on the parabola, I should go out 2p and get a point there. So this line is got a funny name. It's called the latus rectum, and this distance between here and here is called the focal diameter. It's kind of like a diameter of a circle. You go through that focus, which is kind of about as special as the center of a circle. It's not really the same thing, but and this diameter from here to here, well, if this distance is 2p from here to here, in our example, p was 1/4, and this distance is 1/2, then the whole diameter is 4p. And that's a really nice thing to remember. Okay, so one way to sketch a parabola, once you've got the focus and the directrix, the vertex is easy. It's right in between the two, and we'll start out where that's always the origin. And then you can plot two other points quite easily by just walking 2p parallel to the directrix from the focus. Okay, so let me just write that down. So to start sketching a parabola geometrically, we can plot the vertex, which is easy, which is halfway in between focus and directrix, and the endpoints of the latus rectum, which are the number 2p on either side of the focus. I mean, in other words, you go parallel to the directrix. I had this vertically opening parabola, and here's the latus rectum as well, and the focal diameter. Here p was equal to 1. If you walk 2 units over, well, you're still 2 units above the directrix, so that's definitely a point. So 2, 1 is definitely a point here. And minus 2, 1 is definitely a point on the parabola as well. So that gets you 3 points. That's actually not a bad start towards a sketch. If you need more, then it's helpful to actually get the equation. This was x squared equals 4y. So just plot a few more points. Plug in x equals 3 or x equals 4. It turns out 4, 4, and minus 4, 4 were on this. With those 5 points, 1, 2, 3, 4, 5, you've got a pretty good sketch. And it's really helpful to have all the elements, have the directrix sketch, the focus, and the focal diameter, the latus rectum here. and then as many other points as you need to make a nice graph. You really 5 is plenty. For a sideways one, that's a little less familiar, but you can still plug in. Here we found the equation was x equals minus y squared. It's x equals 4py, and p just happened to be negative 1/4. And here the vertex is easy. The endpoints of the lattice rectum are easy. And then just plug in a couple of y values, like y equals 1 gives you, or minus 1 gives you x equals minus 1. And so there's 5 points, and just you've got your sketch of your parabola. Okay, I think that's just barely enough to get you going on the homework.